This is the fourth video on water pricing and tariff design. In this video, I will describe the tariff structures that are currently used in low and middle income countries. The data come from a 2013 report published by Global Water Intelligence. The Global Water Intelligence database includes information on 162 utilities in low and middle income countries. As shown in this table, increasing block tariffs are the most widely used tariff structure in developing countries. 75% of the utilities in the Global Water Intelligence database use IBTs to calculate the volumetric component of a household's water bill. The next most popular tariff structure is uniform volumetric pricing, which is used by 22% of the utilities. Note that these data report the predominant tariff structure that a utility uses. It is possible that a water utility uses more than one type of tariff structure. This occurs if there is a mix of metered and unmetered connections in a utility's service area. The Global Water Intelligence data refer to the tariff structure for the metered connections unless there are very few metered connections. If the vast majority of connections are unmetered, then the Global Water Intelligence database reports the tariff structures as fixed monthly charged because volumetric pricing is impossible. An increasing block tariff structure has four main characteristics or design features. These can all vary from one utility to another. The first is the number of blocks. An IBT must have at least 2 blocks, but it may have many more than 2. The second feature is the prices charged in each block in the IBT structure. The third feature is the size of each block in the IBT structure. Here, the size of the first or lifeline block is often of special policy interest. The fourth feature is whether or not there's a fixed charge, and if there is, the size of the fixed charge. All four features can vary independently, so there are countless ways that an IBT can be designed in practice. Next, I will summarize some of the main variations in IBTs in the Global Water Intelligence database. This table shows the number of blocks in 114 of the 121 IBT tariffs in the Global Water Intelligence database. The most common number of blocks is 3, but there is wide variation. 32 utilities have a 3-block IBT, 23 utilities have a 4-block IBT, and 21 utilities have an 8-block IBT. It is, of course, possible that it makes sense for some utilities to have a few blocks and for other utilities to have more blocks, but this is unlikely. From my perspective, this wide variation in the number of blocks is a good indication of confusion in the design of municipal water tariffs in low and middle income countries. This slide focuses just on the 32 utilities with 3-block IBTs and looks at the volumetric prices in the 3 blocks. Let's look at the median prices charged. The median price in the first block is 34 US cents per cubic meter. By design, this will be far below the average cost of services, providing a subsidy to all households for the water purchased in this first block. But note that the prices in the second and third blocks do not increase very much. Even in the third, the highest price block, the median price is 75 US cents per cubic meter. This is still below the average cost of service in many utilities, which means that the utilities will require continual subsidies. The size of the first or lifeline block of an IBT is usually the amount of water that the utility wants to ensure reaches poor households. The median size of the lifeline block is 10 cubic meters in Latin America, East Asia, and South Asia. The lifeline block is 8 cubic meters in North Africa and the Middle East, and 6 cubic meters in Sub-Saharan Africa. In all 5 regions, the mean size of the lifeline block is higher than the median because a few utilities have very large lifeline blocks. What is striking about these data is that the lifeline block is so large everywhere except Sub-Saharan Africa. 10 cubic meters of water per month for a household with 3 members is over 100 liters per capita per day, close to the per capita water use in many European cities. Of course, many households have more than 3 members, but having a lifeline block large enough so that large households maintain most of their water in the lifeline block will mean that the utility will supply a great deal of water at the lowest price in the IBT structure. In a 2-part tariff, a fixed charge is added to the volumetric component of a customer's water bill. This table shows the number of utilities with IBTs and uniform price volumetric charges that also have positive fixed charges. Most utilities with IBTs also have a positive fixed charge. The mean fixed charge is slightly more than $4, but the median is closer to $2. However, most utilities with uniform volumetric prices do not have a positive fixed charge. It is unclear why utilities with IBTs choose to use a positive fixed charge and utilities with uniform volumetric prices do not. I suspect that one reason is because they sell so much water at the lifeline rate and need another way to increase their revenues. This table shows the size of the monthly positive fixed charge by region for IBT and uniform volumetric tariff structures combined. What is striking here is the big difference between East Asia and Latin America on the one hand and Sub-Saharan Africa, South Asia, and the Middle East and North Africa on the other. The median fixed charge in East Asia and Latin America is $5 compared to $1 in Sub-Saharan Africa, South Asia, and the Middle East and North Africa. Note that the size of the lifeline blocks in South Asia was large and the fixed charges are small. It's easy to see why revenues of so many utilities in South Asia are far below cost recovery. This final slide shows the mean and median price charged by the 29 utilities in the Global Water Intelligence Database that use uniform volumetric prices. The mean price is 39 US cents per cubic meter. The median price charge is 29 cents per cubic meter. These prices are far below cost recovery levels. To conclude, these data from the Global Water Intelligence Database show the popularity of the IBT structure in low and middle income countries. But the data also show that there is wide variation in how utilities design IBTs. Interestingly, most utilities with IBTs add a positive fixed charge to households' water bills. This raises the average price paid by low-volume users, which is, of course, the opposite of what one would want if one accepted the underlying rationale of IBTs, that poor households use less water than rich households. Finally, the data suggests that most utilities that use IBTs and uniform volumetric prices are probably selling water below the average cost of providing services. So we expect subsidies to households to be widespread.